Question 2c. The letters A, E, I, O and U are vowels. Part 1. How many arrangements of the letters in the word algebraic are possible? Firstly, the word algebraic contains 9 letters, and I've written it here on this dash diagram. We're interested in the number of ways that these 9 letters can be arranged among themselves. So we're dealing with an ordered arrangement or a permutation. Now, another point to note is that the two letter A's obviously repeat, so we need to take that into account later on when we're determining the total number of arrangements. So firstly, the number of ways that 9 letters can be arranged among themselves, assuming that they're all different, is 9 factorial. But we need to divide by the number of ways that the repeating letters can be arranged among themselves. So I've added subscripts here just to tell these letter A's apart. So these A's can be swapped among themselves and it doesn't make any difference to the arrangement. And that can occur 2 factorial ways. So the total number of arrangements is equal to 9 factorial divided by 2 factorial, which is 181,440 arrangements. Part 2. How many arrangements of the letters in the word algebraic are possible if the vowels must occupy the 2nd, 3rd, 5th and 8th positions? Just like part 1, we're dealing with an ordered arrangement or a permutation, not a combination. Now the word algebraic contains 4 vowels, of which one of them repeat, the letter A. And I've called them A1, A2, E and I. Now there is a restriction, and the restriction here is that the 4 vowels need to be placed in positions 2, 3, 5 and 8. So we'll need to work out the number of ways that these 4 vowels can be arranged in these 4 positions, taking into account this repetition of the letter A. Then we'll work out the number of ways we can arrange the 5 letters around these 4 vowels. And then finally we'll apply the fundamental counting principle to work out the total number of arrangements possible. So the number of ways these 4 vowels can be arranged is 4 factorial divided by 2 factorial, since the 2 factorial represents the number of ways that these letter A's can be arranged among themselves. Arranging the remaining 5 letters can be done 5 factorial ways. And then applying the fundamental counting principle by multiplying 4 factorial over 2 factorial by 5 factorial to give us the total number of arrangements. And that's 1,440 ways.